Do you guys remember from Friday's lesson how to find the expected counts on a two-way table like this? All right, please go ahead and find the expected counts. It's exactly like what we did on Friday. Find the expected counts. Is there an association between the taco tongue and the evil eyebrow? We looked at this first semester a little bit. The two-way table over here on the left shows the results from a random sample of 600 senior students. Is there convincing statistical evidence that the ability to do the taco tongue and evil eyebrow are associated for all seniors? So how do we find the expected counts? Yep, row total times column total divided by the grand total. So what is our expected yes and yes? Yes, taco tongue, yes, evil eyebrow. 160. And so what would the yes, evil eyebrow, no taco tongue expected be? 40, because it has to add up to 200. What would yes, taco tongue, no evil eyebrow be? 320. And then no taco tongue, no evil eyebrow, the expected count would be 80. Perfect. How many samples were taken? One sample was taken. How many variables were measured for that one sample? 2 different variables. One sample, 2 variables. When we have a situation where only one sample was taken, but we've collected 2 pieces of data about every member in that sample, and we want to know whether or not there's an association or a relationship in that sample. Obviously, if it's a random sample, then we would want to generalize out to the population. Is there a relationship between the first variable and the second variable? And so we call that a chi-square test for association, or you can call it a chi-square test for independence. We want to know, is there a relationship? Is there an association? For significance level, let's use 0.05. For our alternative hypothesis, do you think that we should assume that there is a relationship or that there's not a relationship? We assume that there's not. We assume that these are unrelated things. So in our ha, we're going to assume that taco tongue and evil eyebrow are not associated for all seniors. They are independent. Independent means there's no relationship between these 2 variables. A change in one variable does not affect the other variable. A change in the second variable does not affect the first variable. And so then what would the ha be? Yes, that they are associated, that there is a relationship. That would mean that they are not independent. So this is where calling it a test for independence might help you remember the way to write the ho and the ha. The ho, we assume that they are independent. The ha, we assume that they are not independent. All right. So those are the three things that we need in the choose step. We need the name, significance level or alpha level, and our hypotheses. Then we go on to check. We have to check random, 10%, and large counts. Do we get random? What's it say? Random sample of 600 seniors, yes, or random sample of 600 would be fine. And we care about that because? Lets us generalize to the population, absolutely. Do we need to check 10% in this situation? Yes, because it was a random sample, it was random selection. So 600 is less than or equal to 10% of what? All seniors. If you look back up in that box up at the top, it said we wanted to know whether or not there's an association for all seniors. Why do we care about that? So sampling without replacement is okay, absolutely. This means that we have independence here. And what do we need to meet for large counts? All of the expected are above 5. Are our expected above 5? Absolutely. So you can either write them all down right here and show me that they're all greater than 5, or if you've already done it like we did in the table up above, just make a little note for where this is located. And why do we care about this one? So it's approximately chi-square. The sampling distribution is approximately chi-square. Right. And now we are to the calculate step. What is the formula that we use for all of our chi-square tests? O minus E, what does the O stand for? Observed minus E, expected, squared, over expected, yes. And we have to sum all of those up. So I've got that little summation symbol right after the equal sign, because we're going to have a fraction for every observed count. How many observed counts did we have? We had 4. We had 4 different possible ways that this could be arranged. We had yes to both taco tongue and evil eyebrow, yes to taco tongue, no to evil eyebrow, no to taco tongue, yes to evil eyebrow, and no to both of them. I would like for you guys to calculate the chi-square test statistic, draw the picture, and find the p-value. I'm going to give you guys a couple minutes to do that. So this is another one where the test itself is not on the calculator, so we have to do them by hand. It's only goodness of fit that we've got, unfortunately. What's our degrees of freedom on this one? 1. Number of rows minus 1, which would be 1. Number of columns minus 1, which would be 1. So we have 1 times 1. We have 1 degree of freedom here. Make sure that you write down all of the components of the chi-square test statistic. You always have to show the components. You have to show at least 3 of the fractions, but then I need to see all of the components. In this case, there would be 4 components total. Does anyone have a test statistic, a chi-square for me? 18.75 is correct, yes. Here's all 4 fractions. Since it was just 4, I went ahead and wrote them all down. And the components would be 2.5, 1.25, 10, and 5 for a chi-square of 18.75. Now this one was kind of nice because we didn't have to round anything if you took it out to 2 decimal places. So we have 18.75 and our picture with 1 degree of freedom. And that gives a p-value of what? Yes, 0.0000149. Or I wrote mine in scientific notation because I was running out of room on my paper. That'd be 1.5 times 10 to the negative 5, or 1.49 times 10 to the negative 5. So I want you guys to take a couple of minutes and write the conclusion, including a follow-up analysis if it's necessary. So the only thing about the chi-square test statistic calculation that you wouldn't have to have is you could have left out this middle fraction and just put a dot, dot, dot there. But you got to show at least the first 2 and the last one. So since there was only 1 more, I went ahead and showed that other fraction. But other than that, yes, you have to have all of the components written out separately and then the summation of all of those. Yes. Number of rows minus 1 times number of columns minus 1. All right, let's talk about this conclusion. First part of your conclusion should sound like this. assuming the hoe is true, there is no association, or they are independent. There's a 1.5 times 10 to the negative fifth, or 0.0000149 probability of getting a chi-square value of 18.75 or more purely by chance. So do we reject or fail to reject? We reject. Because 1.5 times 10 to the negative fifth is less than 0.05, we reject the null, and we do have convincing evidence of an association between taco tongue and evil eyebrow. Do we need a follow-up analysis? Yes. What is the largest component of chi-square? 10 is our largest component of chi-square. And that would be this fraction right here. What does that go with from our two-way table? Like this is yes taco tongue and yes evil eyebrow. This one back here is no taco tongue, no evil eyebrow. What's this one? No taco tongue, yes evil eyebrow. And we had much more or much less than expected? Much less than expected. We got only about 50% of what was expected. And so proportionally, what was actually found, how far away that was from what was expected divided by what was expected gave us that component of 10. The largest component of chi-square is 10 because the observed count of yes taco tongue, no evil eyebrow was far lower than expected. Do you guys have any questions for me on this? It runs, as far as the test goes, it runs exactly like our chi-square test for homogeneity. But with our chi-square test for homogeneity, did we just have one sample? No, we had multiple samples. You have to have at least 2 samples for a chi-square test for homogeneity, but it can be as many as you want. And you're checking to see whether or not the distribution between these different samples is the same. With a chi-square test for independence, we have just one sample with 2 variables. So goodness of fit, one sample with only one variable, like when we did the M&Ms. Chi-square test for homogeneity, 2 or more samples, again with only one variable. We looked at the college admissions for that. We looked at OSU and U of M, but we looked at only one variable, admission status. For chi-square test for independence, there will be only one sample taken, just like in the goodness of fit, but 2 different variables looked at. Does that make sense? All right. Calculating the chi-square test statistic stays the same throughout these 3 tests. Your null and alternative hypotheses are where the biggest difference is between these tests. Because we're going to have an alpha level for all of these. We need the name of the test and the hypotheses. Those will be different between the different types of tests, but the calculate step looks the same no matter which test you select. And then our conclusions always look very similar. So I want to take a moment, looking at the check your understanding, to figure out what kind of test we're talking about. I'm going to give you guys about 4 minutes to read through these 3 scenarios and decide whether it is a chi-square test for goodness of fit, a chi-square test for homogeneity, or a chi-square test for independence. Take your best guess given the way those different scenarios are worded. On number 1, how many samples were taken? 1 sample of how many people? 200 people were sampled, but it was just 1 sample of 200 that was taken. So with only 1 sample, what type of test could it be? What do we have it narrowed down to? GOF or association/independence? How many pieces of data were collected about each one of those 200 people? 2 pieces of data were collected about each member of that sample. What were the 2 pieces of data?
Whether they liked pizza and what grade level they were?
Absolutely. Their pizza opinion, whether or not they liked it, and their grade level. And so this would have to be, yes, a chi-square test for independence. This word also jumped out at me. We wanted to know if there was an association, so that was something else that I look for too. But always go back and rely on how many samples were taken and how many pieces of information were collected about each person that was sampled. That will never lead you wrong as far as what type of test we're looking at here. All right, let's look at number 2. How many samples were taken in number 2? 4 samples. 50, 50, 50, 50. 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. Were we guaranteed to have 50 of each class on the last one that we looked at? No. We just had 200 people and then they told us what their grade was. Here we start off by knowing what their grade level is and deciding to use that grade level as a way to pick out this stratified random sample here. So 4 random samples were taken. How many variables were looked at? Just 1 variable, opinion about pizza. So whenever we have more than 1 sample, it can only be a chi-square test for homogeneity. If it's more than 1 sample that was taken, it has to be the chi-square test for homogeneity. The other thing that jumped out to me, we wanted to know whether the distribution of opinion differs. So I'm looking at more than 1 sample and I want to know, are these the same or different in their distributions? Do the samples have to be the same size for us to make this comparison? No, samples do not have to be the same size, but you have to have more than 1 sample. And this last one, how many samples were taken down here? 1 sample of how many? 300. 1 sample of 300. Says that right here. She selects a random sample of 300 orders. How many variables? Just 1 variable, day of the week. And so this has to be goodness of fit, yes. Which again, I am perfectly okay if you abbreviate as GOF instead of writing out goodness of fit. That is a well understood and accepted abbreviation, so you would not get docked points for writing GOF instead of goodness of fit. Do you guys have any questions for me? All right. Tomorrow, you need to come to the Teams meeting and check in with me so that I can count you present for attendance. And then I want you to work on the multiple choice. This is a Canvas assignment that will be graded. You have an unlimited number of attempts. I need to get in and double check that, but the idea is that you have an unlimited number of attempts there. I am going to go ahead and pass out the paper test review so that you have it in your hands, but the homework we will go over on Wednesday. So make sure that you have homework 12-2 ready to go for Wednesday. You guys have the rest of the period to work on that, so almost 20 minutes to work on that homework. And then you can switch over and start working on the test review. Test is Friday.